Hi everyone, this is Kona, and I'm going to talk about one-way ANOVAs, or one-way analysis of variance. So analysis of variance is what ANOVA stands for. It's used to compare the means of more than two independent groups. The independent groups are normally things that you could have used or could have done a two-sample t-test on, but in this case we're doing it all in once. So why not just do multiple t-tests? So technically, one-way ANOVAs could be done by just doing multiple t-tests. But if you did that, you'd have the potential, first of all, a lot more t-tests. You have a greater chance of making a type 1 error, which basically means your results are less likely to hold value or to be accurate. So we do an ANOVA instead of multiple t-tests because we want to make sure that we're providing the most accurate and the best, get the best response possible. So an ANOVA uses an F statistic where you're measuring how much do individuals in the different groups vary from one another over how much do individuals within groups vary from one another. So F is basically between group variability over the within group variability. The initial results of a one-way ANOVA will tell you if there is a main effect of the explanatory variable. The initial results will not tell you which groups are different from each other. So all you'll know is that something is going on, but you won't know what's going on. So to determine which groups are actually different, you would do a post hoc test. And a post hoc test are conducted after a one-way ANOVA if there is a main effect to determine more precisely which groups differ within the ANOVA. So the steps for the hypothesis testing: check necessary assumptions. Each sample is an independent random sample. The distribution of the response variables follow a normal distribution, and the population variances are equal across responses for the group. So in general, most of these we're just going to assume them. So even though we're going to check necessary assumptions, this one's just kind of like a, yep, we did, we're moving on. Write the original claim. So this is really important. This is the only claim you can do right here for your alternative. All population means are not equal. That's it. All population means are equal. That's it. So pretty short, sweet, to the point, right? So here's your claim. And whichever, if you do the null, then here's your alternative. If you use this alternative, here's your null. You would then calculate the appropriate statistic in Minitab. So, and I'll actually go through these in the Minitab example. Is there enough evidence? Look at the F first, and then look at your p-value. So make sure you look at your F just to see what that's telling you. Do you have low, high? And then look at your p-value. So p is less than, there is enough evidence. P is greater than, is not enough evidence. And this is where basically it's the same thing. Make a decision. Null is reject, alternative support, your original claim. If you determine that the population means were not equal, so that's if there is enough evidence to support that all population means are not equal, or if there is not enough evidence to reject. So basically, if you have that main effect, then you would do the Tukey post hoc test to determine whether A, if variables differ from each other, and how do they differ from one another, and then make your real world conclusion. So I know this is kind of short, sweet, but we're going to dig into this a lot more on the actual Minitab example.